Okay, welcome to your new home. We will now, moving forward, we're now going, this is our new setup.
Okay.
I'm going to pull up what we did yesterday. And like, you can treat your Visual Studio Code here as like a workbook. What the? Okay, hold on. Give me 1 second as I pull over everything that we done. So like, these files carried with you for life. Oh, oh, whoops. Wait a minute.
That the whiteboard stuff that we did.
Yeah, yeah. Just moving it over to our new home. Okay. So just to recap from yesterday, there are 4 steps to a design recipe for data definition. So that data definition design recipe. The first step is uh, the representation. What does it mean to a computer? So we say a Celsius is a number. Second thing is interpretation. What does it mean to a human? Third is examples. Okay.
Yeah.
So yesterday we generated some examples. I'm gonna generate one more, which is -40. And I think I'm gonna leave it as that. There's actually one more step to the design recipe, but we will revisit that in the future. That's a mystery. Okay, now I want you to practice what we just did. So I'm going to give you a situation. We are a we are a thermostat software company based in the US. And so all the unit measurements should be in Fahrenheit.
Okay.
I would like you to do what we just did, these 3 steps, but now with Fahrenheit.
So I can type here. Yeah.
Yeah, yeah.
I was looking at the Zoom
Oh,
thing first. So we need representation, interpretation, and examples.
yep. Okay, so that's examples, right? Let's start with the representation. So that's line 22. All right, you want the equivalent of line 22.
I need a hash.
Yeah, so it's a comment. Yeah.
What does CR mean?
Uh, just ignore that. That's carriage return. On Windows, whenever you hit enter, it puts in a carriage return key.
So a Fahrenheit is a number.
Yeah.
Is it spell it like that?
Yes, perfect. So I will capitalize the F in Fahrenheit because this is like a special name which we're going to refer to again and again. It's like a person's name. Okay, what's the next step?
Interpretation.
Cool.
Well,
Nice.
like how hot or cold it is.
Sure.
Do we need more?
I will specify what unit of measurement it is. It sounds redundant, but for the sake of habit, let's just write the unit of measurements on line 38. Excellent. All right, what's the next step?
Examples.
Examples, okay.
Is that enough?
Yeah, I think that's pretty good. Okay, congrats. We're now going to move on to the next idea. So we have data and what we like to do. So basically, just to recap, we have information, we turn information to data. Great. So now we have data. Now what we want to perform operations on the data. So I'm gonna give a situation. We are a thermostat uh, company based in, let's say, London, based in the UK, and we are collaborating with the with another thermostat company, a company based in the US. So we need to between convert from Celsius to Fahrenheit. So I'm going to demo you what this will look like. Okay. So this idea of converting Celsius to Fahrenheit, that's an operation. As we know, how do we do operations? We just write a bunch of things to the computer and hit run and it does stuff. For our purposes, we'll do all that in a function. So I'm going to show you the function design recipe. How do we systematically design functions? So there are four steps. You have seen two of them. Obviously, the last step is writing the body of the function. We also saw tests, well, function header, then tests. Remember that? You write the
Yeah.
function header, ignore the body, write the tests.
Yeah.
But there's actually two steps that precedes that. Okay, and that's what we're going to talk about now. So the very first thing, step number one, is the signature. What are the inputs and outputs in terms of data definition and data types? So on line 57, I'm going to write the signature of our function. So our function takes in one thing and produces one thing. It seems to be taking in Celsius, right? So it looks like it's taking in Celsius and looks like it's producing Fahrenheit. You see that?
Yeah.
Okay. Now there's a second step. So on line 52, the second step is purpose statement. What does the function compute? So looks like produces degree Fahrenheit from degree Celsius. Okay. The rest is what you're familiar with. You write the function header. So I'll call mine Celsius to Fahrenheit. Let's say it takes in C for Celsius. I ignore the body. Again, okay, very familiar idea. And now I write my tests. Okay, so this one you should be familiar with. What's interesting is I'm actually going to reuse the constants that I've defined up top. So I'm going to just copy down below just so I don't have to keep scrolling up. So I
Yeah.
have Cn of. So I'll show you a few interesting ones. So there's a reason why I did negative 40. It's because the result of negative 40 is negative 40. Um, Another good one is this. This is a very common one. Celsius to Fahrenheit. C0 is 32. Classic example. So there are some others that are not very nice numbers. Fahrenheit. So I'll take a number that I feel like is not very beautiful. So negative 0.5. Okay, so what's the answer for this? I don't actually know, and I need to Google the formula.
Yeah, me too. I have no idea.
It's 249. Okay, I found it. Dude, you know, I've done this so many times with so many students, and I never remember it. Okay, I'm gonna paste it down here as a comment. Okay, so what I could do is I could just do this if I'm lazy. So I don't even like do the computation in my head. I just write it out like that. Honestly, I think I could do this one in my head. It's negative zero point 0.9 plus 30, so it's 31.1. Oh, I think should I show you something cool? Okay, I'm gonna show
Yep.
you something cool, but you don't have to remember it. Let me find it. Where is it? Hold on. Sorry, let me find it. Oh my God. Okay. Okay, I found it. Yeah, I found it. Okay. So watch this. You see that?
Yeah, but what does because mean?
So you can explain how you got to the answer with because, and when you run the test, it verifies that you got your answer. Like it also checks like the thing after the because. So this is useful if you want to like show your work and you want to see patterns. For
Mhm.
example, like I can do this one more time. I don't normally show this to people. I mean, I feel like this just got brought up. Okay, let me show this with negative 40. So like, how do we get negative 40? Other than the fact because I memorized the fact that they're the same, I can do negative 40 times 9 over 5 plus 32, right? Uh, negative, wait a minute. Yeah, that's right. Okay. And then it'll be n. You see that?
But you need to write it every time.
It's optional. In my case, it's helpful because it allows me to see the pattern. You see line 64 and line 66? They're super similar, right? All that's
So
different is the first number, is C.
I'm just trying to understand what it does. So it like it checks your answer.
Yes, yeah. That's a good way of thinking about it. Yeah. Um, let me pull it up. Hmm. Yeah, yeah. It's like showing your work. It's all like that. It's like completely optional.
Okay.
It's verifying that the final answer and the thing that led to the answer are both one and the same. You get what I'm saying?
Yeah.
Yeah. If you run this, fingers crossed it passes. Okay. Now here's the thing. Let's say my work is correct. My like for example line 63 and line 64. my work is correct, but let's say I change this to negative 41 and I run it. Do you see the failure message?
Mm-hmm.
So here's the thing. My function is correct. The explanation is correct, but my proposed answer, my expected answer is wrong. And the error message tells you that the expected answer and the explanation do not match for the test.
Yeah,
You see that? So this is a good way of like catching subtle mistakes like this one. So I'm going to change that back and run the test again.
that's
Okay?
nice to have. Yeah.
Okay, I'm just like letting you know this. You don't have to use it, but it's a tool in your toolbox if you want to use it. All right. It is your turn. I'm now going to give you your situation, and I think you can guess what the situation is. So, situation, we are a thermostat software company based in the US, and we are collaborating with another thermostat software company based in the UK. So we need to convert from Fahrenheit to Celsius. All right, your turn. Follow the design recipe.
I have a question about the previous exercise.
Oh yeah.
Um, well, this is easy to understand. We've done this many times before now. But where is the purpose statement?
The purpose statement, line
Yeah.
58.
Okay.
Yeah. It's just like a description in English. All right.
So this is the signature.
Beautiful. Yes. Yes.
I'm too lazy to type this.
Cool.
Uh, well, it's degrees. Is there like is a C assigned for a degree, or do we need to have we
Oh,
can have
so
any random letter?
you can have any random name, but try to keep it descriptive. I chose C because it's short for Celsius. F short for Fahrenheit. That's fair.
So now reading the formula.
Let's skip the. Oh yeah, you're gonna need a formula, but make sure to go to the test first.
Yeah. Oh, now I need to find the formula
Hmm.
because I have no. So it's
You'll also use the thing on the right hand side, the REPL, as your calculator if you want to do some math.
Where?
But, when you click run on the right hand side, a thing shows up and you can like type stuff into it and hit enter. The REPL.
This one.
I can actually see it on your screen. But if you look at the Zoom screen share, I'm looking at it. See that? So yeah, you can use this as your calculator to calculate.
I don't have that on my screen.
Oh, I think you gotta click run first. It'll show up.
There's nothing here.
Wait, what? Really? Can you share screen? Yeah, no, it's right there. Yeah, yeah. You can type 1 plus 1.
Where? Here?
No, 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 not that. To the left, that one. Yeah, the REPL. So just like 1 plus 1. Don't forget the spaces. Yeah, there you go. So you can use this as a calculator if you don't want to do like mental arithmetic.
Okay.
Okay, cool. Okay, you can stop sharing your screen now.
So why is it not moving?
I don't know. I might be. Maybe he's expecting the N at the end to fix the indentation. I'm not sure. Okay, well, that's life. It's just stuck forever. Oh well.
Oh, works fine. I just hmm,
I wouldn't be too bothered by it. Just complete writing the test. Maybe it'll fix itself later. I think maybe because it's like the statement is incomplete, so it doesn't know how to indent it.
Was that enough then?
Yeah, interesting. Interesting. Oh, is it the multiply? What's the minus?
He
Oh,
didn't like the minus. I retyped it and now he likes it.
wow. Is the minus sign like copied from online?
Yeah, yeah, I copied the formula.
Wow, might be a different kind of minus sign. That's interesting. Wait, was that why the indentations were broken?
Possibly.
Yeah, the unrecognized character was messing the indentation. That's interesting. Oh, that's curious. Oh, I know why. Okay. All right. So you're not gonna know this, so I'll explain it. But we can use is here. Okay, I don't know if you remember this from your mathematics days, but sometimes when you divide, you get a really long fraction, right?
Yeah, yeah.
But sometimes you don't write the whole fraction because we gotta get on with our lives. So you just write a few numbers and call it a day.
We try to round it up.
We round it, right? So we're writing an approximation. So
Yeah.
likewise, we got to tell the test we are making an approximation here. So to do that, we write is roughly. Like is
Um,
roughly negative 17.2. So if we run it now, what the heck? Wait a minute. Oh, do we have to add more? Okay, yeah, yeah. So the problem is roughly is that you need to meet a certain level of specificity. So you need to add a few more decimal places.
okay.
So yeah, so change the is to is roughly and add more decimal places.
Do I add any numbers or
Uh,
six?
you gotta run the calculation again and see if like what the actual decimals are. It may very well be a recurring number, but for 17.22222, like those twos are actually the numbers. Oh, so yeah, I just ran the math. It's six recurring. You see the bar on top of the six?
Where?
Do you run the mathematics? Do you run the calculation of 2 minus 32 times 509? It says negative
Press.
16.66.
Yeah,
Like, you see that there's a line on top of the six?
I press it. It's minus 50 divided by 3.
Ah, yeah, so that's the fraction representation of it. So you could also write negative 50 divided by 3. You could also, that's actually not divided by 3. I mean, it is, but it's also a fraction. It's literally a fraction that you can write. So you could write that. You could also just write 66666, similarly to line 80. Yep. Same thing for the last one.
777.
I just ran the math. It looks like it's seven recurring, yeah. So 7777 and whatnot. Cool. Nice. Okay. We're gonna. Do you have any questions on any of this before we move on?
No.
Okay, great. I'm going to close out this session because it's going to expire. I'm going to send you a new link on Gmail. All right?
Okay.
All right. I'll see you in a minute. Okay, so that was like tutorial. What we just did is tutorial. It's very basic stuff. Sometimes you do that, but we're gonna move on to something a bit more important, a bit more powerful. So, what we learned is that we can encode information as either a number. We could also, it doesn't have to be a number. We could also do booleans. We could do strings, but that's kind of limiting. What if we could do more? Like, like if we wanted to like make our own like app, for example, like that's not gonna be enough. We need more power. So I'm gonna show you more power right now. I'm gonna give you a new situation. We are a traffic light software company, so we write software for traffic lights. Um,
Awesome.
yeah. Okay, a traffic light. So, are you familiar with a traffic light?
I've seen it.
Okay, good. I had students where like I say traffic light and um they weren't very familiar with it, which so I have to ask that now. It's like, oh, are you familiar with a traffic
Is
light?
it a classical green, yellow, red, or just
Yes.
green and red?
So it depends what country you're in, but generally it's red, yellow, green. A
Okay.
traffic light has three lights, red, yellow, and green, and it's used to tell cars when to stop, slow down, and go. Okay? But here's the thing, only one of the three lights can be active at any time, right? They're mutually exclusive. Like you can't show red and green at the same time. You can't tell a car to go and stop at the same time. If you do that, you're gonna have traffic accidents. All right, make sense?
Yeah.
All right. So how do I actually, you know what? Let me think about this. How do I want to do this? Okay. So following the steps of the design recipe, I'm going to copy it over from our old file. Okay. I am going to do the first step for you. So remember, the first step on line 14, we're doing a data definition name is a representation. Previously, the representation is a number. Can we use a number here?
Yeah, the one for the computer.
Yeah, so can we use number as our choice of representation?
Yes.
Okay, if we do use a number, how does it represent all of lines 3 to 6?
3 to 6.
Yeah, lines 3 to 6, we have a situation here. A traffic light,
Yes, yes.
red, yellow, green. So let's say I have a number 97. What does 97 mean in that context?
Maybe time between like when red switches to yellow.
Sure, but here we're not talking about time. Let's just simplify the problem. We only care about the fact that there are three lights and each light has a specific meaning.
Okay.
So is number a
So 90,
suitable?
90, no.
Wouldn't be, right? Okay, how about strings?
Yes.
Okay, in what way
Green,
strings?
well, for the color, green, yellow, and red.
Ah, okay, so not all strings, right?
Yeah.
It's like three specific strings. Okay, so this is something new, which I'm going to show you now. I'm going to show you a new form of data. So previously we saw using primitive data types as a form of data representation, like a number. Now I'm going to show you enumeration as a choice of representation. So the word enumerate means to like how do I say this? It's like to list a set of finite elements. Okay, how about this? No, no, no. I don't like that. That's just a word list in there. A set of finite elements. Does it make sense?
By finite, you mean the ones that are gonna end eventually.
Countable, yeah.
Countable, okay.
Let, let's say like countably small. There's a mathematical definition to it, but for now, for our purposes, it just means countably small.
Okay.
So, for example, like for example, strands of hair on a person's head, assuming they have a lot of hair. Is it
Yeah.
finite or infinite? Like technically it's finite, but like you're not gonna count each strand of
Well,
hair.
they regrow,
Sure, but
so
like if you take a picture of someone's head at a point in time, you say like count all their hair.
well, that's
Yeah,
gonna take forever, but yeah.
yeah. So yeah, for our purposes, it's countably small. So I'm gonna
Okay.
show you this to write an enumeration form of data. There are two ways. That's the better way, and there is the less better way. I'm gonna show you the worst way first because it's more familiar, and then we'll show how we can improve this. So first write is a colon new line. And then you write what are elements of this set. So what are the elements of this set? Can you tell me again?
String,
Yeah, what are the strings?
green, yellow, and red.
So green, yellow, and red, right?
Yes.
Okay. Well, let's give this data definition a name. What name do you want to give it?
Color.
Like this?
Yeah.
Well, that's not a bad name, but the problem I have with this name is that in theory, color could mean like purple, blue, right? Could we have a more specific name?
Traffic light.
Traffic light. Okay. So I'm going to use title casing here. Notice how it's one word. Capital T,
Yeah.
capital L. So whenever we use traffic light, like capital T, capital light, capital L, we are referring to our data definition here.
Mhm. It has to stay the same.
What has to say the same?
Like, well, traffic light. Like if we're gonna use say a function needs to maintain capital T and capital L.
Yes, exactly. Yeah. Whenever we're referring to the data definition, yeah.
Yeah.
Okay. So I'm going to change is not grammatically correct. I'm going to change it to is one of. So a traffic light is one of green, yellow, or red. Okay. I'm going to share my screen on Excalibur again from same as yesterday. So if you could swap over,
To zoom.
yeah. Sorry, I paused my sentence. Yeah, swap over to Zoom. I believe this was you yesterday, right? This is your stuff here.
Yeah.
Okay. So let me tell you what we just did. So we know in our box of strings, among of the infinite number of things, we have red, yellow, and green. Remember that?
Yeah.
So just like you say, we wanted to say, oh, a traffic light is a string, but the problem with saying is a string is because it involves other strings like goodbye and deletion. But if you are trying to create a smaller circle inside S, which is essentially what we did is we created a smaller circle and we gave that circle a name. We called it traffic light, capital T, capital L. Okay?
Yes.
You see that?
Yep.
So, okay, it's back to this idea that when we're making a data definition, we are drawing a circle in our universe of data. Whatever's in this circle is a traffic light, and whatever's outside of it isn't a traffic light. You see that?
Yes.
Okay, so let's go back to Visual Studio Code. All right, so this is step one, representation. What is step two?
Interpretation.
Okay, could you give us an interpretation of traffic light? What does it mean to a human?
The traffic light indicates when to stop and when to go.
Sure, okay.
If you're crossing the street, or if you need to stop or drive if you're a driver.
Cool. Okay, let's write it down on line 21. Perfect. Uh, what's the next step of the design recipe?
Examples.
Examples. Okay, what are some possible examples we could make?
Traffic light, green, yellow, and red.
Okay, can you show me?
Do we need hashtags here?
No. So far, this is the one place where we don't use hashtags because we actually want to refer to our examples in our tests.
Well, because it's like we can't call each string traffic light
So you
because
have
it
to give it
would
a more
give it.
descriptive name.
Can I do? Can I just TL1?
We could, but it's kind of hard to remember that one is associated with a specific color, right? Can we use a more descriptive name?
Can I call it green for green? Or
Sure.
is that
Oh, yeah, sure. But I would capitalize the green though. So it's a bit of a convention. Like all capitalized. So REEN is also capitalized.
all of it?
Yeah. It's a convention as to say it's a constant. It's something that doesn't change.
Why do we need to do it? Uh, I'm sorry. Why do we need to capitalize it?
It's to tell other people. So like let's say that other people working with you, when they read it's all capitalized, they know, oh, this is a constant. This is something that doesn't change.
Okay.
Yeah. Perfect. Can we write more examples or is this it?
No, there can only be one at a time.
Ah, okay. So here's an observation to make. We can only have as many examples as there are elements in the finite set. Right. With numbers, we could like spend all day coming up with all sorts of numbers, but here we stop at three because we only have three elements in our set, right? This is a special property of what do you call it? Enumeration. Okay, cool. So far, so good. Uh, yeah, let's keep going. We have 8 minutes, but I think we have time. So I'm gonna give us another situation. Our traffic light needs to change lights. Let's create a function for that. Let's design a function for that. So, we need to a traffic light needs to rotate between lights. So, for example, if the light is green, it needs to go to sorry. Yeah, yeah. If it's green, it needs to go to yellow to slow down. If it's yellow, we need to tell it to you gotta go red. If it's red, it can turn to green. Make sense?
Shouldn't be the other way.
Wait.
Like red, then yellow, then green. Like yellow means to slow down,
Yeah, you
and
slow down
then
once when you're moving, right? So green is when you're moving, and then you slow down when you're moving. So green to yellow. Does that
why
make
red
sense?
to be?
Oh, so like red is stop, right? Now you're saying now you can go.
Yeah, okay. But should okay, yeah, yeah. By why yellow to red then?
So yellow slow down, right?
Yeah.
So once you're slowed
Slow
down,
down.
you will stop.
Yeah. Okay. Yeah, 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 yeah.
Okay, cool. All right, we're on the same page now. Okay, so we need to design a function that changes the lights as so. What's the first step of the design recipe for functions? Oh, let me copy that actually, so you can refer to it.
We need to
Uh,
define the function and then write tests.
okay.
We need
So I just basically in the recipe at the top. What's step one?
function header.
That's step three. It's two steps before that.
But haven't we done signature already?
What's the
The
signature?
input, like the green, yellow, red.
That's not a signature. That's like me giving you the rules.
But these are the rules.
Yeah, but that's not a signature, right? This is just like an informal explanation of the rules of how the lights should change, but it's not the signature. Remember, the signature must refer to our data definition, right?
So we just type the strings then.
So let's remember in our previous file we had Celsius to Fahrenheit. What was the signature of that?
Celsius to Fahrenheit.
Yeah, line 57 of our previous file.
Yeah, Celsius to Fahrenheit.
Notice how we use the words Celsius and Fahrenheit, which are the data definition names we've came up with.
Yeah,
We need the same thing here for our traffic light.
but so red to green just with capital letters for
Uh,
RNG.
oh, actually not. No, so green, yellow, red, these are just like, okay, so let me change out the arrows. Those are not signatures, that's just an informal description of the rules. So for our signature, right, we're talking in terms of set. Remember the diagram of the circles just now?
Yeah,
We need to use the names of the set. So what's the name of the set that we're dealing with
traffic
here?
traffic
Traffic
light
light. So yeah, let's say traffic light. Capital T and L. Perfect. So how many things does this function take in?
3.
It takes in three things.
Well, it takes one at a time.
So as far as you're concerned, it's one thing, right? It's one thing that could be three things, but it's ultimately just one thing. Yeah.
Yes,
Okay, so what does it produce?
produces one traffic light,
Yeah.
one color,
Well, traffic light, right? It's not just any color, it's red, yellow, green. And what describes red, yellow, green?
like our definitions here.
Yeah, definition of traffic light. So yeah, can we say traffic light, arrow traffic light? Oh, remember, we got to refer to the name of our set, so the capital letters do matter. Great. All right, and what's the purpose statement of our function? Step two?
And we need to change the lights,
Yeah, sure.
like function function that computes change of color of traffic light.
Yeah, perfect. Great. We don't have to write function that because we already know that's a function, right? So we can just write computes change of traffic light. Okay, we are out of time. Okay, good work, good progress. We've covered all the ground. You are welcome to write this function at your own time.
Okay.
Yeah, we can pick it up the next time. All right, good work,
Um,
Victor.
but yeah, time flies fast with
Yeah,
you.
man.
So yeah. So thank you for doing this.
Yeah, no problem, Victor. All right, I'll catch you next time. Bye bye.
Thank you. Bye.